My name is Pavel Kučera. I work here at Penny, and I would like to show you how you can use Typescript's mapped and conditional types in a very practical way, hopefully. So you don't have to love type theory in order to understand the talk. Again, hopefully. And I'll show you how to enforce validations using this. I have a confession. I'm lazy. I actually think it's a good thing for a programmer. And because I'm lazy, I want a compiler that thinks for me, which is why I'm using Typescript. And even better, I want a compiler that yells at me when I make a mistake. And this is sort of an overarching topic for me, making the compiler yell at me more. And this is what I'll be talking about today. My running example, what I want to demonstrate this on is, let's say we're saving an article. We're working backend using Typescript with Node.js. And we have some JSON coming in, and it's an article that we want to do something with the article, but it's actually not that important what we're doing with it. If we're saving an article and we're working with Typescript, we're probably going to define a type for an article. And making a simplification, let's say an article is an object which has two properties. It has title and string, title and text, and both of these properties are of type string. Then we would have a lot of boilerplate that would be able to take incoming HTTP request, take out its content, parse JSON, and then give it to us. So let's assume this boilerplate is there. We don't see it, and then it passes the contents of the request to our save function. And then we're assuming that we're getting article of this shape in here, and this works all very well and nice, and we can use cool auto-completion in our IDs and such. But it will stop working immediately when someone sends request which is of different shape. They send a number, they send an object of a different shape, and then we get runtime errors because there are no runtime checks of the types with Typescript. So everything we're declaring, we're just sort of believing, hey, this is what it is like. Unless we make some validations on the system boundary where we can enforce, hey, so if we get an HTTP request with some JSON, let's validate that it's actually of the type and shape that we're expecting. And one way of doing these checks is using package happyjoy, which will use to demonstrate mapped and conditional types. But there's a bunch of other options. When using happyjoy, and when we would like to make these validations for an article that we defined before, so we still have an object or record with two properties being title and text, both of them being strings. This is what we would do with Joy. We would say, hey Joy, we're making schema for an object, and that object will have two properties, title and text, and use the string validator for these two properties. And then when we work with some input, so we have an incoming HTTP request, we parse it, we pass it to our save function, and we get it as the input here. We can say, hey, Joy, with the schema we defined before, validate this. And then if the validation succeeds, we know that the input is of the shape we've defined in the schema, which gives us more control and more safety. Does it mean we're done? Sadly, no, because one day someone will come and they will change what's happening and they will add a property, but they will add a property on the type. And that will work. It will type check. You can use this property, and as long as the input is of the expected format, it will work. But then again, one day someone will come and send input of the wrong shape, and the publish on date property that we've just added will be of something that we're not expecting, and we will get runtime errors. So how do I get a compiler to yell at me when this happens? And specifically, I want the compiler to yell at me in two cases. If I forget to define a validation, And if I define a wrong validation, so I say, hey, here I'm expecting a number, but actually I'm expecting an object. And that's how I'm finally on slide 16, getting to mapped and conditional types. I'll now walk you through what you can do with map types and conditional types, and specifically how you can use them to enforce validations. So map types they allow you to create types based on already existing types. And essentially it's like calling map, but instead of calling map on a list of values, we're calling it on a type and on the properties of a type. And by type, I mean object type. To demonstrate how you can make a map type, let's say we want to make another, so we have this type article that we've defined before, and just for demonstration purposes, let's say we want to define another type which is exactly the same as article, but we are lazy. We don't want to list property by property what's in article. Let's call it new article. And this is where we can use map types. I'll introduce the syntax now, sort of step by step, where when making a map type, we have to map over something, and then the syntax is it's a type as any other object. And then we're saying, hey, iterate over something. And here we're saying, iterate over the properties of type article, and then assign their name into type variable that's called prop name. So in the case of article, this would iterate through title and text. So now we've created a new type that has two properties, but these properties are not assigned any type yet. That's what you do on the right-hand side of this sort of equation. Here, I could write anything. I could write Boolean, I could write number, I could write string, and then all the properties that we took from the original type would be in the new type with this specific type that would be Boolean, string, or whatever. But if I want to use the original type, I just write, hey, okay, the type of this property in the new type is the same as the type of the property in the old type. This is all what it's doing. And then for all purposes, we could use new article as exactly the same as the old article. And I can show you that's what actually happens. Let me zoom in. Is this big enough? Can't really make it. Cool. So as on the slide, I'm defining a type article with two properties, title and text. And as on the slide, I'm defining a new article, which is a map type over article. And here I'm defining a value, which is of the type new article. And now I've defined both title and text, so it all works. But if I remove a property, I suddenly get a compile error. And here, if you can't read this, it's saying property text is missing in type blah blah. But the important point is that it actually gives me an error. Hey, you haven't defined this property that should be there. So that works. That's nice. And now to make it slightly more complicated, if you would always have to define some specific type to map over, that would be that could be very annoying to use. So you can actually make generic types where you don't specify what you are iterating over in the beginning. So here I'm I'm using wrong button. Here I'm defining a type map that has a type parameter, so that's generic, and at the definition time we don't know what that will be. And once the type checker actually does its type check, it specializes to something else and does more. But essentially we're doing exactly the same. We're saying iterate over the properties of the base type and then assign the same type in the new type as in the old type. And to show you how to use that, so again, talking through the syntax. And this is how we would define the new article type that was defined on previous slide, just by specializing the map type. In general, map types allow you to do multiple transformations. They are not that important, so I'll just run quickly through them. You can make properties read-only. You can make properties required, or you can make required properties optional, and then you can set the type of every property as either to something specific or to the original type of the property in the original type. There's a lot of types. So this addresses my first goal, that the compiler yells at me when I don't define validation for a property, because I can define a type that checks that for me. To walk you through what's happening, in the beginning I'm just importing things from Joy, the validation framework, and a type schema. The type just says, hey, this is something that can validate input. And then I'm defining a generic object, a generic type, map type called object schema that will, when it's specialized to a specific type, it will look at all the properties and then say all the properties should be of type schema. And then when defining validations for article, we would say, hey, we're defining schema, and the schema is for an article. So then I have to define title and text that are validations. To show you how that works, and this is exactly the same thing as on the slide, where in the beginning I'm just importing things from Joy. Then I define the type that performs the checks for me. And then when defining the type article, it's exactly the same as before. And when I define a schema, and I define only schema that's specifying title, but not text, I get a compile time error. So again, if you can read it, this is saying property text is missing in blah, blah. Important part is that it gives me a compile time error. And if I specify text there, the compile error has disappeared. So that's cool, works, which is surprising since I'm doing a live demo. It will probably stop working eventually. Does that mean we're done? Sadly, no. The problem now is that when I define, I still don't have checks that I have defined validation of the appropriate type. And I can make a type article where I'm saying, hey, now we want to work with multiple authors. And an author is an object which has property name. With defining this, I can still define validation that says author is just a string. And with the types that I've defined so far, this will type check. And it will look like it will work, but we will likely get a runtime error one day. Which is how I'm getting to conditional types. Where conditional types allow you to make a type that is variable when type checks the type checker does its checks. It will specialize it based on some condition, and this condition is happening on type level. You cannot use any runtime values. To introduce the syntax, conditional types use just regular ternary operator. So nothing new. You just define a type with some condition, and then if the condition equals true during type check, then the final type is the type from the true branch. Otherwise, it's from the false branch. To give you a very stupid and silly example of what you actually could do, you could define a type new Boolean, where with this condition, which is just saying, if Boolean is Boolean, so it will always evaluate to true, which is why it's rather useless. But this is so you can see how you define these type level conditions. Generally, you say, if some type extends other type, use this type, otherwise use this other type. This would be rather stupid if we couldn't make this generic, because it wouldn't really give us any babbling. Sorry, I'll use a different word. So we can make it generic to make it work better. And it's exactly the same as before. We define a type that is parameterized with another type. And then if this type extends Boolean, or if the type is Boolean, then the final type will be Boolean, otherwise it will be string. And this is how we could use it. If I define a value of the type Boolean or string, specialized to the type string, I can assign it a string value. But I cannot assign it a Boolean value, because string here doesn't extend Boolean, and therefore the false branch of the condition will be evaluated. And we can nest, as any other ternary operators, we can nest them, which allows us to define multiple conditions. We don't have to define just 2 branches and then use another type. We can actually nest this as much as we need. It looks horrible, but it works. Which addresses the second goal I've had, that I want to check that I've defined appropriate validation for appropriate type. And don't panic, I'll walk you through this. This is how you can use this specifically with Joy. On this slide, we're again importing some types from Joy. These are used when we create specific validations. So when I create validation for a string, the value will be of type string schema. If I create validation for a Boolean, the value will be of type Boolean schema, and so on. Which then means that I can define a conditional type saying, hey, I'm having some property schema, and then if the property schema over this generic property type is specialized to Boolean, then this should be a Boolean schema. If it's a string, it should be a string schema, and so on, till we hit the case where, okay, if it's an object, or ideally a record, then this should be of object schema, which is a type we defined before. And to show you how this actually is combined together, this is almost exactly the same slide as before, just saying, defining an object schema, type object schema, which is able to check any kind of objects and define appropriate validations. So it's a map type over some generic type object, and then it will look at all the properties of the type object and will make sure that all the properties or that the validations for specific properties are of the appropriate type. And I think now it's time for demo to show you how all of that works together. There's more things happening on this slide, but it's essentially the same things as you've seen in the slide. First, I'm importing types and values from Joy. Then I'm defining this long property schema, which makes sure that if the property type, when specialized during type check, if it's a Boolean, then use a Boolean schema. If it's a number, use a number schema, and so on. And then importantly, when it's an object, then it should be an object schema. And then I can, as in the slide, define this object schema, where just it says, looks at all the properties of this object type, and then all the properties should be of the appropriate validation schema type. So now when I have an article, as before, it has title, text, and then author, who is a name. And I define validations properly. So I say title should validate a string, text should validate a string, and author should validate an object. It works. But if I say an author should be validated by a string, I get an error. Again, if you can't read this just say, it says, hey, there's property name is missing some things that should be there. Which is exactly what I wanted. So it works, and we're actually using it, and it saved us a few times. And this is actually it. So thank you for your attention, and